If you have Zigbee devices as part of your smart home, then you know that there are some great sensors out there, but it can also be a big pain when things start to go wrong. So today I'm going to help you get a reliable Zigbee network by telling you about all of the things that I have learned whilst managing my Zigbee network. There are quite a few things you need to do and check to get a solid Zigbee network, so I'm going to go through them one by one so that you can see which ones you have in place in your Zigbee network. I'm sure that you will have heard about some of them before, but I'm also pretty sure that some of them you won't have considered very much. So grab your laptop and a drink, and probably one of these, and let's dive in. So let's start at the beginning with the coordinator of your Zigbee network. You will only have one of these per Zigbee network, but there are quite a few to choose from. The good news is that things have come quite a long way in the past few years, and as long as you pick a fairly well-known coordinator, then you can be fairly confident that it's up to the job. Having said that, I do have some recommendations. I have had a stable Zigbee network with the Sonoff dongle-p, the Sonoff dongle-e, and the SM Lite SL ZB06M. But the Home Assistant Connect ZBT1, which used to be called the Sky Connect, or any of the other SM Lite devices are also good options. The next thing to consider is the firmware being used on the coordinator. There are various things that I could go into here, but I'm going to try and keep things quite simple if I can. The latest firmware available is called Ember, and as of the tail end of 2024, I am finding this to be quite a good stable firmware to use, particularly if you have a lot of devices and a mixture of Zigbee 1.2 and Zigbee 3.0 devices like I do. The Ember firmware is only available for Silicon Labs based coordinators though, and so for this reason my top recommendations are the SM Lite SLZB06M, the Home Assistant Connect ZBT1, and the Sonoff dongle-e. The next couple of things I'm going to talk about you may have explored before, because they are fairly common troubleshooting tips that seem to come up a lot, but they are both still valid and worth talking about. The first one is to ensure that you either connect your coordinator to USB 2 port, or if you're using a USB 3 port, then you must connect your coordinator using a good USB extension cable. If you don't do this, then the interference can make your devices very intermittent. I've used the Amazon USB cables for multiple dongles with good success. Another tip is the placement of the coordinator dongle itself. This is obviously going to depend on where your Home Assistant PC is placed and how long your USB extension cable is. Ideally you want to have it central in your home if possible, but that's not a deal breaker and we'll talk a bit more about that later. But the important thing is that it has good clearance in all directions. Ideally you don't want to place it near metal objects or even too close to a wall. Metal objects will affect your signal a lot, but also having it really close to a wall will make it more difficult for the signal to radiate effectively. So I would recommend trying to give 20 centimeters or so clearance in all directions. So there's one more thing that I want to talk about in relation to the coordinator before we get into some of the other considerations. When you have a Zigbee network, it of course uses radio waves. And annoyingly, airspace is a precious commodity, with lots of devices using the same or similar frequencies. For Zigbee, this is 2.4 GHz, which means that if you don't choose your Zigbee network carefully, then it's going to interfere with yours or your neighbour's Wi-Fi network. The best options are either Zigbee channels 15 or 20, as this will minimise the interference from common Wi-Fi channels. If you only have one wireless access point in your home, then ideally use channel 15 for your Zigbee and Wi-Fi channel 11, because then it'll only be other people's Wi-Fi or potentially Zigbee networks that will interfere with yours. Great, so now we've got all of that sorted, we can talk about adding devices to your Zigbee network. Again, I'm probably going to talk about some things that you've heard before, but also things that are less talked about. You probably know that you can have two types of Zigbee devices, routers and end devices. End devices talk to either coordinators or routers, and routers talk to coordinators, end devices, or other routers. Routers are the things that allow you to extend your Zigbee network further than the range of your coordinator, but there are lots of things that can go wrong when introducing routers into your network. So in this next section, we're going to talk about these various things that you need to consider when adding routers. Most devices that you plug in act as routers, and so I would recommend only trying to get Zigbee 3.0 devices to get the best compatibility. If you get some devices which are the previous standard of Zigbee 1.2, then you will likely get it to still work, but there's some features in Zigbee 3.0 that just don't exist in Zigbee 1.2. For example, your network will downgrade its level of encryption to support the Zigbee 1.2 devices. The next critical thing about Zigbee routers is that you need to ensure that they are on all of the time. If you have Zigbee smart bulbs that sometimes get their power turned off at the switch, then you're guaranteed to get problems. And because of how Zigbee mesh networks work, you might not get issues straight away. It could be days or even weeks until you start getting issues. And we'll come on to why this is the case in a minute. Ideally, you want to have a good balance between the number of routers and end devices in your network, but your smart home might end up being router heavy or device heavy. If you have a lot of routers, then there's not much you can do about that. As long as you've got Zigbee 3.0, then you should be okay. But on the other hand, if you have a lot of end devices and not many routers, then a really good option here is to have a couple of routers that just act as routers. Most Zigbee coordinators can be flashed with router firmware, and because they're designed to be coordinators, they usually handle a lot of end devices. If you place a couple of routers either side of your coordinator about 8 meters or so apart, then this is going to give you good coverage over quite a large area, meaning that these 3 devices alone are going to allow you to have a network of up to maybe 100 devices. One thing to consider is that if the transmit power is too high on your coordinator, then it might be able to see your end devices that are far away, which typically have a lower transmit power themselves. This asymmetric signal strength might cause an end device to hold on to a weak signal. If you look on your Zigbee map and you see that a lot of devices are connected directly to your coordinator rather than a nearby router, then it might be worth reducing your coordinator's transmit power a bit. Great, so you now have a Zigbee coordinator in a good location on a channel which doesn't interfere with your Wi-Fi, and you've got a bunch of Zigbee 3.0 routers which you're going to keep on 24/7. We're nearly ready to talk about connecting your end devices such as battery powered sensors, but before we do that, there are a couple of settings that we want to check in either ZHA or Zigbee to MQTT, depending on which one you use. Although Zigbee meshes are supposed to be somewhat self-healing, they are not very clever. And so to help this work a bit better, you want to ensure that you set the availability timeouts for both active and passive devices appropriately. Thankfully, the defaults in Zigbee to MQTT are already quite sensible. I would recommend something between 10 and 30 minutes for routers and 25 hours for end devices. This means that not only will the Zigbee network itself know that the device is offline, but it also means that you can set up some alerts for offline devices as well, whether that's having to repair it or maybe change the batteries. The reason that you want the timeout fairly short for routers is because client devices only actually communicate with one router, and so if that router goes offline, then all of the end devices that are communicating through that router will also go offline as well. At some point, these end devices should start to communicating through different routers instead, but this duration can be device dependent and some devices might just not bother. And this nicely leads on to pairing your end devices and why setting the timeout for passive devices should be set to 25 hours, depending on the devices you actually have in your network. When it comes to advice for pairing Zigbee devices, a lot of different information is flying around, such as pair the device in its final location, pair it next to the coordinator, or pair it next to a router. Most of the information is valid, but it does depend a lot on the devices that you're actually trying to pair. If I take my Aqara Zigbee blind controllers for example, these are Zigbee 3.0 devices, and although they run on batteries, there is a big battery in there because it needs to power a motor, and so the pairing process is not very battery intensive. For this reason, I would recommend pairing something like this or a radiator smart valve in its final location where they will reside. This is because it will likely choose the router with the best signal for it to communicate through, and you can be fairly sure that as long as you keep that router online, then the communication will stay fairly reliable as well. Now, if we consider something like contact sensors or PIRs, then these typically have very small coin cell batteries, which makes the pairing process the most battery-intensive operation that the device will ever do. I have also found that in the UK at least, it can be quite difficult to find coin cell batteries which actually turn up with a full charge, even if you buy them from a shop which is generally intended to sell batteries. If you combine a partially charged battery with the Zigbee pairing process, then it's possible or even likely that halfway through the pairing process, the voltage is going to drop enough that the device restarts itself halfway through and therefore fails to pair correctly. Now, before telling you the simple solution, I'm going to quickly bore you with some information about signal attenuation. Signal strength gets exponentially weaker with distance rather than linearly. This means that if you try and pair a device that's far away from a Zigbee coordinator or router, then the signal is going to be weaker, leading to more message retries and therefore prolonged battery usage. You can probably see where I'm going with this by now. I would recommend trying to identify what you believe is the closest router to the device's final location and pairing it directly next to that router. This will give you the best chance of pairing the device successfully and save on some of its small battery capacity as well. This is particularly useful when pairing old Aqara or mid-year devices, which can be quite fussy to pair anyway. Now, this leads me on to a couple of my final bits of advice for battery-powered Aqara sensors. The reason that you want to set the passive device timeout to 25 hours is because if an Aqara sensor isn't used, for example, it doesn't detect motion or the contact sensor isn't triggered, then it can go an entire day without sending any messages to your Zigbee network, which often leaves your Zigbee routers thinking that the device has gone offline. But even with this setting, I've found there are some situations where the device pairs fine and then it works for a few hours okay, but then it stops working. I found a weird solution to this which has worked for me a few times. For the first 6 hours or so after the pairing process, then you want to trigger the device once per hour. For example, if it's a PIR, then walk past it. If it's a contact sensor, then open and close it. And if it's a button, then press the button. I'm not really sure why this seems to work, but I think it's probably something to do with the routing and the neighbour tables that are stored in each of the routers. If this still doesn't work for you, then you might need to try and pair it either to a different router or directly to the coordinator instead. So the final troubleshooting tip I want to mention is that if after all of this you've still got intermittent issues, then it could be that you've just got a problematic Zigbee device on your network. I've mentioned that you can get some routers which don't work well with some devices, but also some devices are just poorly designed and they send too many messages which overwhelms the Zigbee network. The more modern coordinators with better firmware are also possibly masking an existing issue until you get to a certain number of devices. An example of a problematic device is these 2mm wave sensors. It's such a shame because these work fairly well as present sensors, but they send distance updates every second. If you had one in each room of your house, then it's likely that it wouldn't give much airtime left for any other Zigbee devices. Some clever people in the community have started reverse engineering the firmware, but the update process didn't seem to be very simple, so for now 2 of mine are sitting on the shelf doing nothing. Well, that's a brain dump of most of the issues that I have come across while dealing with my Zigbee network over the years, and I hope that this has been helpful to you in some way or another. So thanks, until next time.